Yes. In the last video, I said that I was interested in sort of moving past looking at shapes in order to judge fractions, and this next assignment, this next topic, is exactly what I need. This is equivalent fractions number lines. Let's go. So now, instead of looking at fractions as pieces of a solid object, right? Up to this point, we've used a solid object and we've like cut it into, let's say, 9 pieces. Yeah, and each one would be 1/9, 1/9. And this is the only way we've really looked at this up to this point. But fractions are so much more than that. They're so much more versatile than just cutting up a solid object into equal pieces. A fraction can also represent a certain number of steps to get between 0 and 1. So in this case, there are 1, 2, 3, 4, 5, 6, 7, 8 steps between 0 and 1. So each step is going to take you 1/8 of the way in between. In other words, this is 1/8 right here. This is 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and then 1, which is the same as 8/8. Essentially, using fractions, we can take the distance between 0 and 1 and cut it into equal pieces, just like we did with the solids, though in this case, it's a little bit more abstract. And in this case, we see that A is on 6 out of 8, 6/8. Now, yes, I do want to, at this point, make sure I stress that when I say 6/8, that literally means 6 divided by 8. Yeah? We have divided the distance from 0 to 1 into 8 equal segments, and we have traversed 6 of them. This is 6 divided by 8. The number of high school students that I get that don't realize that the fraction bar and division mean the exact same thing is frankly concerning. We should be teaching at the very earliest levels that a fraction is a small division problem. Not a problem, but it's a small bit of division. Okay, so in this case, we are at 6/8. I thought it was 6/8. 1, 2, 3, 4, 5, 6/8. Yes. 6/8 is equivalent to 3/4. It does equal 6/8. Can you see how? Using what we've figured out so far in this video and the video before, can you see why those two are the same? And while you're thinking about it, can you think of any shortcuts that you might use to be able to go back and forth between those equivalent fractions? If you want another hint, once again, go check out my video on the weird number. It's one of my sort of top viewed videos, so you should be able to find it pretty easily. Moving right along. Move the dot to graph 5/3 on the number line. Now it tells us that we've got 6/3 right here, yeah? So that would stand to reason that this is 1/3, 2/3, 3/3, 4, 5/3, and 6/3. So the dot would go right there. Again, getting students used to the idea that a numerator can be bigger than a denominator is very important very early. I think that some students get a block on so-called improper fractions, specifically because they are called improper fractions and treated as though they are somehow different from other fractions, which they verifiably are not. Now it says, move the dot to graph a fraction equivalent to 5/3 on the number line. Now this is super easy because the two number lines are exactly the same size. I can just drag the dot so that it lines up properly. And then I can count how many sixths, there's that word again, how many sixths is this? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sixths is the equivalent of 5/3. And yes, you can say 10 over 6 or 10 out of 6 or that sort of thing, if that, or even 10 divided by 6, if that works better for you. Again, I apparently cannot pronounce the word sixths properly. Moving on. Use the number line below to help you complete the equation. So what's this number line showing us? That's kind of an important piece that sometimes we skip past. Let's take a moment, look at the information they're giving us, and try to decide what it is they're expecting of us. So it's showing us on the top that we're dealing with fifths, right? 5 over 5. And then it tells us that is equivalent to 1, which is true. And then we want to know how many eighths is equivalent. And it looks like it did break this up into 1, 2, 3, 4, 5, 6, 7, 8 pieces. And our highlighted point is the 8th on that path. So it is indeed x equals 8 over 8. Again, shouldn't be terribly surprising, but we are laying the foundation for understanding things like when you divide a number by itself, you always get 1. Why? This is why. Sometimes it's easier to show than to try to explain, if that makes sense. One more. Which fraction is equivalent to the point A? So again, the first thing we need to know is how long is each one of these steps. They're not labeled, but there are 1, 2, 3, 4 of them to get from 0 to 1, right? You have to take 4 steps to get from 0 to 1, which means that each step is 1/4, which would make this 2/4. That would make this 3/4. That would make 1 4 over 4. Again, anything divided by itself equals 1. And then A is 5 over 4. Again, I cannot overstress that we need to step away from the idea of an improper fraction and just teach fractions as fractions. Fractions are confusing enough as it is without throwing unnecessary adjectives around. 5 over 4. Now, which of these is equivalent to 5 over 4? Well, that's the same thing as 10/8. If I have 5/4, let's actually go ahead and do that. These should be the same size. In fact, I can go ahead and resize it to make them the same size. No sense in confusing the issue. There we go. Those are roughly the same size. If I have 2 boxes that are the same size, I cut them each into 4 pieces, and I highlight 5 of those fourths. So 1, 2, 3, 4, 5. Yep. And if instead I wanted those fourths to be eighths instead of fourths, I want to cut each square into 8 instead of into 4, well, I would just take each fourth and cut it in half. Yeah? Again, we are setting up some really powerful ideas here. The fact that 1/2 of 1/4, if I were to cut this in half, 1/2 of 1/4 is 2/8. That is a mathematical equation I just said, and right now we're just kind of coming to grips with the idea. So if I wanted to cut these squares into 8 instead of 4, I could just split it down in half the opposite direction. I've got eighths here, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them are now highlighted. 10/8. And that's equivalent fractions on the number line. We are moving right along.